Well, greetings, mathletes, and welcome back. Not surprisingly, we're going to be talking about lines today. Not so much the graph of the lines. We're not going to concern ourselves too much with that today, but we are going to concern ourselves with the equations of lines and how they're used in statistics. Now, in most contexts, y equals mx plus b, that slope-intercept form that we've been using, is perfectly fine to use. The thing is, though, in statistics, and this is one of the few contexts that it's different, we actually look at a different form of the equation. All the same information is there, but it's presented a little bit differently. And so we need to adjust to that so that we can understand how this is going to be used in statistics. And then we're going to actually apply this to some actual situations and see what information we can get out of these equations to enlighten us. So, without any further ado, let's go ahead and get started here. All right, so the main difference, what we're used to seeing is let's switch that. Okay, hang on. That's too thick. It's going to do this crap again. Okay, there we go. Let's try that one more time here. So we're used to seeing y equals mx plus b, where m is our slope, and b, well, actually, I should say the point 0b is our y-intercept. Okay, now, in statistics, it's different. The form of the line is y equals a plus bx. So b is now your slope, right? That is actually very strange and very annoying to someone who has gotten used to looking at it this way. So notice too, right? So the slope is over here. The slope is what's attached to x. If I wanted to write it in the same order, it would look like y equals bx plus a. And so a is our y-intercept and b is our slope. So statistical form, right? The statistical form looks like this. And the reason for it actually is because it's usually used to find estimations of things. And what this does is it makes it very easy to make a better estimation by making this polynomial bigger, right? If I have an x squared term, I actually get a better estimation of this particular thing. So we're not going to go into all of that. We're just dealing with the linear estimations. In fact, most of statistics does do the linear estimations, but that is part of the reason for why it's written in this form. So now b is our slope, and what's even more is we're not going to be calling it slope anymore either. I mean, it is a slope. You're not incorrect by calling it the slope, but we're going to be calling it something else. And then 0a is your y-intercept. Okay. Now, the slope in statistics, typically we call this a marginal change. Right? So if we're talking about the marginal change in something, what you're actually looking for is the slope. Okay? So we're going to go ahead and jump right in. That's the extent of the translation between the two forms. You just have to understand that things are written in a different order, and you're using completely different symbols to represent the exact same thing. Okay, so I want to take a look at some actual applications here. So let's delete that. And okay, so suppose you own a widget company, right? Doesn't matter what widgets are. That's a little shorter than saying whatchamacallit. So anyways, let's say we're producing widgets, right? And it turns out, in fact, I want to call this total cost. So it turns out to produce 50 widgets, right? And that's everything we're producing. If we're going to produce 50 widgets and that's all we're producing, um, it costs the company $210. Okay, to produce 100 widgets. Now, normally you would think, oh, well, it's going to cost $420. No, it costs $250 to produce 100 widgets. Okay, so we need to figure some stuff out. So, first of all, we need to know what is the marginal cost of of producing one more widget between 50 and 100 widgets. Just looking at this, I'm going to type the next one. So we want the marginal cost of producing one more widget between 50 and 100 widgets. Now, here's why they have to put that 50 to 100 widgets in there, is because we're assuming that there's a line between these 2 points. And you can actually look at this as your X value and this as your Y value. Right? There's a line that goes through these 2 points. But that line is only accurate between the 2 points, right? And there's really no guarantee that it's accurate between the 2 points either. It could go all over the place in between there. But if we're going to find the marginal cost here, well, what that is our slope, right? Remember, we have the form of the line a plus bx, right? So the marginal cost is b. And b, again, is a change in y over a change in x. What this really is are 2 coordinates. And you can just find the equation of the line between 2 coordinates, 2 sets of coordinates. We've done this before. This is a slope, so we're looking at y2 minus y1 over x2 minus x1. So y2 minus y1 would be 250 minus 210 over 100 minus 50. So that means that, let's see here, that's 40 over 50. And if I do that division, that's 0.8. Or since we're talking about money, I'll put the 0 in so I can see that it's 80 cents. Okay, so the marginal cost of producing one more widget, once I've produced 50 widgets. If I want to produce one more, it costs 80 cents to increase by 1, right? That doesn't mean that it costs 80 cents per widget. That's a big difference, right? If it's 80 cents per widget, then it should not cost $210 to make 50 of them, right? Because that's less than $1 a widget. It should be less than $50. So what this actually is just the marginal change. It's how much one more would cost, not what the total average is. Okay, now what that means is we can if we really want to, we can start to put this in an equation. I know that, in fact, let me switch colors so we can see this. Y is equal to A, remember, because A is your y-intercept, plus 0.80x, right? So there's going to be some cost, and then every additional widget costs 80 cents. Okay, well, if we really wanted to, we could go ahead and find A as well. That wasn't asked for, but it will be asked for in future problems. And if you want to do that, what you end up doing is you pick a point, just like we did before, and you plug that point in, and then you figure out what A has to be. So we've already done this computation, so I'm going to go ahead and get this part off of here. Since we already did the slope computation, I want a little more room here. Okay, now we can pick either one of these points, and I think 50 to 10 might be the easier one to deal with. Although 100 and 250 isn't, oh, actually, you know what? Multiplying by things by 100 is easier. So I'm going to go with that. So we're going to use the point 100, 250 to figure out what A is. Okay, so X is 100. So Y is 250. And A we don't know, but over here I have 0.80 times 100, right? So if I multiply that by 100, it's 80. So now I have 250 is equal to A plus 80. And if I go ahead and just subtract the 80 over, right? Let's see here, 25 minus 8, which should be 17. So 170 is equal to A. And so we have our full equation now. Y is equal to 170 plus 0.80x. Now, this is our incremental change in cost, right? For every additional unit, that's how much gets added. The question then becomes, what does that 170 mean, right? What does that actually mean? It could mean different things, but most of the time it represents some initial cost, right? Like you have to buy the widget making machine in the first place, then it costs $170. So to make your first widget, you have to buy the machine, and then 80 cents is the cost of materials and running the machine. So that's the part that changes. But the 170 doesn't change because that's a one-time purchase. You don't have to buy a new machine to make each individual widget. You buy one machine and then start cranking them out, right? So this is a fixed, in this context, this is a fixed cost, right? That's a cost that's not going to change. You pay it once, done. It's a startup cost, if you will. And then 80 cents is how much it costs to make a widget once you've made that investment, right? So there's actually a lot of information in these equations. Okay, so let's go ahead and look at the next thing here. So let's go ahead and kill that. And this one we need to type. Okay, so here's our next problem. I want you to go ahead and read this and see if you can set it up. I'm gonna wait until after you guys work on it to read it, because reading it is part of the skill. So I want to make sure you guys can read this and tease out the information correctly. But let's see how you do. There's some information about a movie rental here. And go ahead and pause the screen so you can get all the information down before we get started here, and see what you can get. So go ahead and pause it here, and then we'll take a look. Okay, so it looks like we got this down. So let me back out a little bit so we'll have some room here. That should, in fact, let's scoot this over. We'll do that. That'll give us the most room. Okay, so we need a couple of things. One of the things that we always need if we're trying to find the equation of a line is 2 points, right? So that's what we have to figure out. We need to figure out what are our unknowns, what are the things that we don't know, and kind of go from there. So let's see here. So first of all, we have a couple of points here. I can see that 3 movies is tied to $24.20. Right? So it looks like we got number of movies and then cost. So it looks like those are our 2 variables. Those are the things that are relating to each other. And you notice when I change the number of movies, the cost changes. So that means one depends on the other. Okay. So the number of movies, we know that at 3 movies, the cost changed to 24.20. Right? That's the number of dollars. And at 8 movies, that makes it $31.20. So those are actually 2 points. I have the point 3 and 24.2, and then I have the point 8 and 31.2. Okay, so the monthly fee, we have the monthly fee and the marginal change in cost per movie. So we need to know how much our bill's going to go up if we rent one more movie. That's what the marginal change means. It's always in reference to one unit. How much is it going to change if one unit is changed? right? If we go one more movie, how much does the price change? All right. So that means movies are X and the cost is Y. And incidentally, what that means, since the cost depends on how many movies you pick, that means X is what's called a dependent variable. So X is really what decides everything. Um, or excuse me, Y is, I'm sorry, Y, Y is the dependent variable because X decides everything. The value of Y depends on what the value of X is. Okay, now let's look at the equation of the line we need. We need Y equals A plus BX, and we know B is our marginal change. And A represents any one-time costs or anything that's a startup type of a thing. So the monthly fee is going to be A, and B is going to be the cost per movie, right? Because X is the number of movies. So as I change the number of movies, the we can see how that'll go up. So let's go ahead and start by finding the slope. We'll find our marginal change first. So it's the change in Y, 31.2 minus 24.2 divided by 8 minus 3. So let's see what we get there. Where did I put my calculator? There it is. So 31 minus, oops, try that again. 31.2 minus 24.2 comes out to 7. And then 8 divided by 3 is 5. And if we go ahead and do that division, 7 divided by 5 is 1.4. And we'll just go ahead and put the 0 in because we're talking about money. So it's $1.40 per movie. That's the additional cost. So you pay your monthly fee, and then for every movie after that, it's another $1.40. That's why they call it a marginal change, because it only changes if you change the value of X, and it's just, yeah. Okay. Now, so that means we have B here. So we can go ahead and write that in. Y is equal to A plus B is now $1.40, 1.4 times X. We need to find A. And that's where we pick a point and plug it in, right? It really doesn't matter which point we pick. I could use this one or I can use this one. Both will work. So I'm going to use the one with smaller numbers. So that means that Y is 24.2 is equal to A plus 1.4 times, let's say I use the smaller one, so that's 1.4 times 3. So 1.4 times 3 is 4.2. So it's 24.2 is equal to A plus 4. It's 4.2. And we just need to subtract 4.2. And if we subtract that, well, you notice this ends in 4.2. That ends up being 20 is equal to A, right? And that was the last piece we needed. So now we can write our full equation as Y is equal to 20 plus 1.4 times X. Notice too, we can use this to predict. Now that we have a line that actually describes the cost for any value of X, I can work out how much it's going to cost me for 10 movies. I can work out how much it's going to cost me to rent 100 movies. I can work out all of that stuff, and it won't be any deal, right? All you have to do is just plug something else in for X if you want to know how much a different number of movies will cost, right? So that ends up being our answer right there. Okay, so let's go ahead and look at the next one. You notice all we're really doing is finding the equation of a line. The only real difference here is that we're teasing it out of a situation, and we're writing the equation in a slightly different form. That's the only difference. None of the rest of the stuff is any different than what we've been doing up until now. Okay, so here's our next problem. So take a moment. Let me go ahead and zoom in on that a little bit, make it a little easier to see. Oh, too much. There we go. Okay, go ahead and get the information down on this. And so if you need to pause it, whatever you need to do, and then we'll go. I want you to go ahead and see if you can answer the questions that are being asked. There's three questions here. So go ahead and see if you can work through the problem, and then we'll take a look at it together. So pause it here. All right, and you notice that these are actually starting to look a little more like the type of data you might find in real life. Okay, so we have some things to find here. Let's see here. The workout, the work, the Outwork workout. I just messed myself up. The Outwork Workout Apparel Company sells athletic attire, and they find that when they spend $1,000 on ads, they sell 73,540 items of clothing. When they spend 4,000 on ads, that jumps up to 98,290 pieces of clothing. What's the marginal increase in cost per $1,000, right? So for every $1,000 they spend, how much more are they getting? That's basic. How much more are they selling? That's basically what that's asking. So again, we're back into this situation where we have y is equal to a plus bx, right? And we want the marginal increase in cost per thousand. Okay, now that gives us 2 points. And we're actually told that the amount spent on ads is X, but that's our dollars. And then Y is the number of clothing, the number of items of clothing we sell. Now, since X is in thousands of dollars, right? So if you look at this, $1,000 is just one of those thousands of dollars. So um, when I spend one of the thousands, I sell 73,540 items of clothing. When I spend four of those thousands, we sell 98,290 pieces of clothing. So we have 2 points here. I mean, that's exactly what we need for slope. So if I want to find the slope, it's going to be the change in y. So 98,290 minus 73,540 over 4 minus 1. Now, if you use the thousands in this, what that does, it changes X from being in thousands of dollars to being in single dollars, right? So this 4 represents 4,000 and this 1 represents 1,000. So we just need to work this out now. So we'll pull out the old handy dandy calculator, and we got 98,290 minus 73,540. If you're putting this in the calculator and your calculator has a comma button, do not use the comma to separate the thousands part of that. Okay, so that gives us 24,750, right? And that's for every 3,000 spent. So we'll just go ahead and divide that by 3 now. And that gives us 8,250. Okay, so that's our marginal cost, or marginal increase. I keep saying I keep saying cost because of the last thing. So what that means is that we sell 8,250 more items of clothing for every $1,000 spent on advertising, right? So if I spend $1,000, I can expect my sales to go up by 8,250 items. That's the expectation there. So that means, so we have a little, we can write this down. In fact, let me do it this way. I'm writing a different color. So now what we just found was B. So it's A plus 8,250X. So what we need to figure out now is A, right? We need to figure that out. And remember how we did that before? We just picked one of the points and plugged it in. So I can just use this first point. When X is 1, Y is equal to 73,540, right? I have that marked right there. So we'll go ahead and work that out. Let's see here. So y is 73,540, and that's equal to a plus, let's see, b was 8,250 times x, and x is 1. So that makes my math a lot easier because multiplying by 1 is easy. So now we just need to subtract that over. So if I subtract 8,250, right, so we have 73,540 minus 8,250. Did I plug that in? Yeah. So that gives me that I get 65,290 as A. And I could have sworn I switched that color back and I didn't notice it. Oh well. So that's our value of A. So now, let's see, where can I put this? I need somewhere where there's room. I'll just write it up here. So now we have all the pieces. We know what B is and we know what A is. So the final equation is y is equal to 65,290, right, plus 8,250 times x. Okay, so now the task is to decide what that y-intercept means. So we found the marginal change in cost, right? Or the marginal, the marginal change in sales per cost per $1,000. We found what A is. It's 65,290. What does that mean? What does that 65,290 mean? Now, basically what that is your y-intercept. And so what that's telling you is what the value, how many items of clothing will be sold if there is no advertising at all, right? Because if I make 0x, or if I make x 0, it basically cancels this term out, and all you're left with is this. So that means that they're not spending any money at all on advertising, and they're still selling 65,290 pieces of clothing. So that's what the y-intercept represents in this particular case. It's always a little bit different, right? It's good to think of it sometimes as an initial value, right? Because it's the first value you get wherever you have 0 marked. All right. So that wraps up our little excursion into applications. So from here, we're going to be jumping. Let's see here. But we're going to be jumping around a little bit. We'll see what things we get to next. So in any case, until next time, keep your pencils and your wits sharp.